Good morning, everyone. Following on, and I think a lot of it will be of a sort of similar idea from what Alini was just outlining. But what I'm hoping I can do today is kind of show you my learnings from how I've got to where I am as a sort of now principal computational designer at Ramboll, and the learnings that I've taken throughout my educational and my career in order to try and give some insight into what the challenges current graduates facing and how potentially it can be some of these skills and challenges can be incorporated into teaching in order to help this new wave of people going forward. So before I start, I just want to say why I think it's really important, because I think that the sort of environment and the architecture of how we're working is starting to change. We obviously still have those traditional domain experts, you know, the engineers coming from all different backgrounds, but we're also starting to see this sort of influx of new domain experts. This can be software engineers, front-end web developers, and, you know, this is not just limited to digital, it can be broader than that, but for the sake of this discussion topic, it is the digital sphere. And more commonly, and definitely it's getting more and more, we're also now starting to see these hybrids in the middle, who are those who have a little bit of the expertise in sort of the more traditional engineering domain, but also some of that in that sort of digital sphere. And I think that this new team and skill set is really exciting to see, because I think it's really helping the industry to sort of tackle problems differently, tackle some of the sort of productivity, environmental, social value issues that our industry is at the forefront of being able to solve. And I think what's worth noting at this point is that I believe that each of these roles are equally valuable, and businesses and the industry are starting to see the value in each of them. And I think that hasn't necessarily always been the case, and it's definitely starting to increase, but these hybrids, who I would say I am now one of, I would class myself as one of them, have had some challenges trying to sort of carve out more sort of defined career tracks for this. But I think what is clear is whether you're an engineer that has that traditional domain expertise or whether you're the hybrids, you need to have some at least digital skills / knowledge to start to really leverage and benefit how technology is starting to influx and add into the industry. And also as a way of being able to now communicate and work with these new domain experts that are coming in. Because otherwise we have this problem that we have two great sets of skills, but if they can't combine and work together, then we have a problem. So I thought today I would run you through how I sort of became a hybrid. And if I'm honest, I became a hybrid slightly by accident. When I first started my career, I was definitely someone that wanted to be a, you know, traditional engineer. I had my life plan, I had all my life goals set up. And I went to the University of Bath to study civil engineering while I was there. And I was trying to think back and have a look at my career. At what point did I first come in touch with digital coding or any kind of skills in that area? And actually what I remember is a project that we did in MATLAB, which now looking back on it, I look at it and it was actually a really cool project. We were taking pictures of a sort of wooden stick and putting weights on it, and then we were using MATLAB to kind of work out what the Young's modulus of that stick was. And if I'm honest, and this is not a criticism to the University of Bath or my lecturers at all, I don't think I appreciated it at the skills that I was learning at that time. But actually, you know, in hindsight, looking back, I think it's actually really cool. And I think what I was missing at that point was the context. I was viewing MATLAB at that time as a way of doing the task and passing that course. And I think that's maybe a sort of mindset shift that engineers sometimes fall into, at least some of the ones that I've fallen into, is that we're trying to get the task done and you know, we're very logical and that's what we want to achieve. And so what I thought now looking back is that actually if I'd had a little bit more idea of the context of how this, you know, very basic photogrammetry methodology could be used in a wider context, how it could be used to change the industry, that maybe I would have viewed the problem slightly differently. And I'll kind of touch back on about the reframing of problems going forward. And then by accident, I did a summer placement at Ramboll Computational Design team. And this is where I got introduced to the world of Grasshopper and Rhino and a little bit of C#, so a little bit of coding, in order to help to create this sort of timber pavilion. And this started to make me step a little bit out of that sort of traditional engineering mindset, or at least my traditional engineering mindset, about how you could use technology to start to play and kind of try different solutions to the problem that you saw in front of you. So following this, I then went on to the University of Stuttgart. So I was signed up to do the master's at the University of Bath, but I decided to leave a year early to go out to do a new MSc out in Germany, which was a slightly terrifying prospect because, as I said earlier, the sort of traditional engineer in me was very concerned about how I was going to get chartered. How was this going to affect my career route? And I had lots of worries about what that was going to do. But while I was there, I was fortunate enough to be working in a team that contained biologists, computer scientists, architects, engineers. And actually it was here where we were given a place to test and create and how to use digital skills in order to create something that had no Euro codes or design codes behind it. And so we were essentially making it up as we were going along. But what we had to do here was that we really had to learn how to present and create the argument for what we were doing. Because there was nothing to follow, no rules, no set logic to necessarily follow, we had to learn how to test, fail, learn from that testing. And the digital sphere is a place where that really allows that to happen and really facilitates it, because you can test fast, you can learn, you can tweak. And here is really where I sort of broke out of that box of being a pure engineer and actually showed me how digitalization allows you to transcend more than your specific discipline. From being there, I learned little bits of expertise from robotics through to biology, through to computational design techniques, and all of these little bits I've now taken to my career and apply them in different ways. And predominantly it comes from how to listen, communicate, and trying to understand the perspective of other disciplines in order to incorporate it into digital tools and products. So then I've started going into my career, and I guess here I want to discuss some of the challenges that I've faced being this hybrid. And if I'm honest, the main one was I going to get chartered? Because that was obviously a life goal from when I was very young. And as you can see, at the end of last year, I managed to achieve said goal. But I think what's important for us to teach at university level is that having that digital skill set does not mean you don't have the engineering skill set, and you should value the fact that you're able to have both. And I think the industry and companies are starting to value that and realize that as well. And similar to what Eleni said at the very end of her things, that digital is not an add-on, it is definitely much part of the process, and that actually having those digital skills can sometimes really reinforce the sort of base knowledge that you have, because you actually have to really understand the theory in order to apply it into digital tools in a way that's useful and ultimately correct in what it's doing. I think the other piece that has been challenging, and I've actually been very lucky on this side, is that you have to have managers and colleagues that support this kind of career path and know how to manage projects where you're trying to apply digital transformations or new digital tools as part of the process. And there are definitely, engineers that either are very fixed in the way that they want to work, they don't know how to manage a project differently, and ones that do want to have these digital skills, but they just don't know how to communicate this or how to apply it to a problem. And I think we're currently in this sort of, I guess, ugly zone where, as more and more of these sort of digital hybrids come through, this will become an easier challenge to face. But at the moment we have this mix where there is a sector that doesn't know so much about what's out there digitally, how it can be applied to projects. And so one of the key skills that I've learned here is around arguing your point and understanding why what you're doing is going to make a difference and how to manage a project differently. So digital transformation often requires a little bit more of a greater investment of time, capital, resources at the beginning of the project in order to set it up correctly, to really understand the parameters that are defining it, or to actually develop the solution. So if you're developing a piece of software, for example, it doesn't just happen like this. And that's a different way of working from the traditional route, which typically happens as you start to create work, and the sort of amount of things that you've created sort of naturally goes upwards. Whereas with digital, there is this lull at the beginning before you start to see the impact of it. And being able to work out how to manage and project manage in that way has been a skill in itself. So what are the kind of key skills that I think I wish I'd learned, or maybe, you know, parts of it I've learned more of throughout my career? The first one, I guess, is around the actual practical skills. I always started doing visual programming in Grasshopper and a little bit of coding from a little bit at university and at my master's in Stuttgart. And to be honest, these are the two that I think personally have really driven a lot of the basis of the knowledge of what I've needed. Visual programming is a very accessible way of starting to understand the logic, to start to understand the principles of the problems that you're trying to set up. And is a very good starting place, I think, as a skill set for people coming into our industry. It's fast, it allows you to fail fast, and it allows you to learn very easily. Moving on to coding is another kettle of fish. It's very difficult because everyone uses different coding languages. Everyone has sort of, you know, different ways that they want to apply creating applications or software and different levels that they want to achieve. However, I do think it is an important thing to start to understand the logic, but making it clear that it's simply the syntax or the sort of language between, I guess the common thing is that you can learn French and Spanish, or that they've got very similar structures, but you're just kind of learning the different words that go behind it. So I think that's important. But one thing I think is that engineers are naturally very good at this. And, you know, they're very good at understanding the concepts, the logic, the structure, the principles of coding. So I think that that's, you know, these are skills that engineers can pick up very quickly. But I think this digital sphere is very broad. You know, there is lots of different digital skills being applied, everything from robotics, more different types of or specific areas of coding, such as through machine learning, neural networks, everything from digital twins to IoT. It's huge, this area. And there's no way that you can teach all of it. However, I think that there is a space that you can create which allows for you to set a problem and allow for different people to take their own different tacks in order to learning those different sets of skills. And that's something that I really learned at the University of Stuttgart, that we were given the problem. And actually, it was up to us to argue, create, use whichever technologies we thought were the most appropriate in order to deliver that problem. And I think that's something that can be set up very easily within teaching. And it's just about sort of reframing the problem. So it's not about we're going to do X, Y, Z and learn the theory behind it, but saying this is the problem. These are various digital skills that, or techniques that you can use your intelligence to kind of take various aspects of that in order to, you know, approach the problem. And this is very true because I think this area is going to continuously change, and it's going to be changing, you know, within the next 5-10 years. And so I think it's really important for us to kind of get the perspectives of new people that may have different ideas to see what's coming up. And I really think that can really help push innovation, both in academia, but also in the industry. And sort of similar to what Eleni was saying, that in parallel to that, there is the softer skills that have to go alongside that. And this is the part which I think I've definitely learned less when I was at university and more through having to face the challenges of my career. And this is partly kind of knowing how to apply digital skills, digital softwares, or whichever you're going to use to a problem. Because previously I thought, oh, I've got these skills, it's really cool, but I didn't necessarily know how to apply them in order to make things that both created an impact on my projects, my company, and my clients ultimately. And then the part on top of that is then being able to articulate that process. As I said earlier, you often have to persuade people to make an investment early on in a project. And so being able to understand the why you're wanting to do it and how you're going to do it, and then what you're going to achieve is super important, I think, in order to communicate and really push sort of digital innovation within the industry. And I really learned a lot of this actually when I was lucky enough to be part of an innovation accelerator as part of Ramboll, where we were sort of bidding to receive funding for a digital tool that we wanted to create. And there we really had to get to the crux of the problem, which is what are the pain points that clients or whoever you're trying to solve the problem for are, and what can you do to solve that problem and create something that's useful for them. And it was really hammered home with the sort of the analogies that many people create cool digital tools or create cool concept, cool products. They go to market and they realize actually that's not something that anyone wants and won't pay for. And they've spent however much money, however much time investing in it. And so actually really going back to those principles, kind of the basic knowledge of why you're trying to achieve something, I think is something that we should try and embed in teaching much earlier on, whether it be through a sort of business style part or a management style course. I don't know, I'll leave it up to you experts. So just to kind of conclude, what I think my summary is when I look back on this course is that I don't think you actually have to change very much. I think it's about doing similar projects to what you're doing before, just maybe reframing them, having a different setup, which allows for a little bit more play, a little bit more freedom in how you approach it. I think this is important because I think it doesn't take away from the theory that you're learning, because I think you have to really understand the theory to apply it on these digital levels. But what I think is really important here is that the outcome of that will create this new kind of thinking. And I think it will be new thinking in the ways that lecturers don't necessarily know how to mark or how to evaluate, because they might not have experience in that area. But I think what's really important is then if you also train the sort of, these are the arguments, these are the reasoning, this is the steps, this is the process, then actually this is how we can really put in new thinking, new ideas, new innovation in the industry, and both which could affect academia and the industry and the workplaces in total. So thank you very much for your time, and I look forward to your questions.